Okay, in this video I'm going to use this example to explain the code that I've written for the array sum problem. So, in this example I'm using k as 1, and this is the list of integers we're going to try to sum up to make 1. So the first step is simply to sort this, that's simple enough, and then we're going to put in two markers, one at the beginning, one at the end, and then we're going to sum these two together and compare it to k. In this case it's a match. Minus 6 plus 7, or 7 minus 6, is indeed 1. So first we're going to count that. So we've got one match so far. And then we're going to move these markers here. So we're going to move this one up. But we're going to move it as far as it needs to go to get to a new number. Obviously we don't want to be comparing the same number again. That would be a waste of time. So we're going to move that one up to minus 4. Here we're going to do the same thing. We don't have to skip a step here since we've got a number right next to 7 here. It's a 3. So then we sum these up and compare that to k. In this case, we get minus 1. Now this is inferior to k, so what do? Well, knowing that these are ordered, we know that by moving this marker up, the sum is only going to get larger as we go up this way. And moving this marker down, the sum is only going to get smaller. Well, we've got minus 1, we want 1, we want it to be larger. So we're going to move this marker up 1. Now we've got 3 minus 2, that's another match. And when we get a match, we move both markers, since we obviously don't want to compare the same numbers multiple times. So we move both. Alright, now what have we got? Well, now we've got 2. That's too high. So again, we know that by moving this marker down, we're getting a smaller sum every time. So we're going to move it down. Now we've got 0 and 1. That's another match. And we move both markers. In this scenario, this is the end. We're done comparing everything here because our marker is in the same position. As soon as the markers cross, the algorithm ends. So the algorithm ends and it'll output 3.